Hello class and welcome to the lesson on permutations and combinations. Now, disclaimer here, you may hear my son Caden in the background, and this is his first time joining us on one of these recordings. So, if you hear him, my apologies. I'll do my best to edit it out. So, let's get started. Now, permutations and combinations is a topic that is close, near and dear to my heart, since I've already mentioned to you before how this lesson was something that I memorized growing up but did not fully understand. So I'm going to work on making this a painless process for you to understand. So let's get started with the definitions first. So here we have the definitions that a permutation is where order matters, and a combination is where order doesn't matter. So you can see how these permutation and combinations are opposites of each other. And what does it mean order matters and order doesn't matter? Well, that is specifically referring to is the number of outcomes a situation can have. AKA, if I had to pick my outfit for tomorrow, does it matter which item I pick first? AKA pants, shirt, shoes, or does it not matter? In which order? So these type of problems or understanding permutations and combinations comes best when you're able to actually apply some of these concepts to an actual example. So let's put one up. So here we have how many different ways are there to deal a hand of 5 cards from a standard deck of 52 cards. And A being order is important, order important, and the other one is order is not important. So I'm going to do the first one in blue and say that in this case A is going to be over here. If I have these boxes, right, 5 cards, 1, 2, 3, 4, 5, I'm looking at how many exist. Well, 52 is my first amount of how many cards I'm picking from, then 51 because I've now drawn some, 50, 49, I can write, 49 and 48. And obviously we multiply this out to get 311,875,200. And that is the total number of outcomes that exist when order matters. Now, that's how we did it with this step, but we also can find it's actually a really nice formula for this. So in this case, for permutations, we actually have a formula, and I'm going to put it down at the bottom left, NPR. Okay? And in this case, permutations can be rewritten as your n being, so n is going to be your total number of the set, so number of the set, and r is going to be the number of choices. So in this case, I would end up writing NPR as 52p, and the choices being 5. Now, you may automatically recognize this as a function in your calculator, and you can do that. But I am going to go through in how we actually calculate that. All right? And showing that in blue still, it's going to be simply derived by saying that n is going to be n factorial, the numerator, divided by, and this is where you're taking the difference of n minus r factorial. And note, we actually have this derived already. Now I'm going to point to it. Here is going to be equal to this. It's actually very much related, if not the same thing, because we have 52 factorial in the numerator, right? We're going to have 52 minus 5, which is going to be, in this case, 47 factorial, right? Well, if you have that all listed out, and I'm going to draw this out, 52 times 51 times 50 times 49 times 48 times 47. I'm going to stop there on purpose. Draw a line, and then we have 47 times 46 times 45. I'm going to just put dot dot dot. No, I should have put dot 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 there too. Note that as soon as we start going through this, we start saying, okay, well, we have 52, we have 51, but all the way at 47, that's where we have this repeating. And that's where we start canceling them out and every other subsequent term later on. And we're left with this here. and that's going to give you A. Alright, so let's look at now order not being important. First off, I want you to think about a question here. What is larger, permutations or combinations? AKA, which one's going to have more outcomes? Just generally speaking. So think about that for a moment. And if you're struggling with this now, I'm just going to simply give you a quick example and say, if we're trying to rearrange the word mom, right? We're trying to rearrange the word mom. This mom here, we have 1, 2, 3 letters, right? If I were to rearrange this, I have certain combinations that exist, but mom here, if I switch the 3 and the 1, right? If I switch the 3 and the 1, aren't they essentially the same word? The M here is not exclusive. They represent the same thing. So in this case, I went from, if it was a permutation, 2 different words. Mom switched with that one would be the mom and the M in the 3 positions to the first and the first and the third. That would be 2 different outcomes. But in a combination, they're like, hey, same mom. No difference. That does not give you the right to go to your mother's tonight and say that your mom can be just simply switched. Let's avoid that. All right, on to serious business. So I'm going to do this one in green and say for green here, B, in this case, we're going to have these outcomes still, right? We're going to still have these outcomes that exist. We're going to actually divide here this number here. I'm going to highlight it. This number here, so this area, these numbers here, by a countdown for actually how many or what position we're actually looking at, I should say. So if we're looking at the 5th card position, that's 5, 4, 3, 2, 1. And we can actually write that as multiplication as well. I should have put that above. But basically, in the green and blue here, this would end up giving you your combination. So let me rewrite it for the bottom. So 52 times 51 times 50 times 49 times 48. And that's all over 5 times 4 times 3 times 2 times 1. And that's going to give you 2598960. And note that yes, this is still a very large number. It is smaller and fewer outcomes than the permutation outcome. So let's go through this formula specifically, and this one's also N but CR, and that's going to be written as 52 C5, and this is also written as N factorial, but not only N minus R factorial, it's also by another R factorial. So it's going to be 52 factorial over 47 factorial multiplied by 5 factorial. Again, these formulas are in your calculator, being able to plug these in, but you should understand how they are written and how the N here again refers to the number in the set and R is the number of choices. So let's do one more practice problem. So here I have a question. A teacher has a collection of 20 true and false questions and wants to make a quiz, hint hint, of 5 questions. How many variations exist if the order of the questions matter and if the order of the questions doesn't matter? So, give it a try and we'll go over it together. Alright, let's start off with A and say again, we're going to be saying that order matters. So in this case, we're looking with permutations, and this is going to be equal to 20p5. Okay, and if we're doing that, reminder, we have 20 factorial over, in this case, 15 factorial. Because if we're actually looking at this, we're going to say we have the boxes again, 1, 2, 3, 4, 5, and we're going to fill those in with 20 times 19 times 18 times 17 times 16. And you should get that answer, but we're also going to do it in the calculator. And I want to mention where you get that. You're going to be going to and I'll write this on the side, math. Okay, you click that button, and you're going to go to next, you're going to go to prob, that's the prob tab, and then you're just going to find the right NCR and PR. It's the same process for either one. So I'm just going to put in red NCR. Okay? So you're going to go math. I'm doing that myself right now. And PR. And now some calculators versions you have to do this earlier. You have to plug in the N before you go to this step. So be careful about that and don't forget it. Okay? So in this case, when you do this out, you're going to get an answer that states that this should be equal to 1,860,480. So let's move on to the next one. Okay, and in this case I'll do this in red. This is going to be NCR, it's a combination, and this is going to be 20C5 equals. Now this setup, we're going to look at it as 20 factorial over 15 factorial multiplied by 5 factorial. As a reminder, that's going to look like the above, and I'm going to copy this and paste it. There we go. And say we have this option, but then we also want to say that when we're counting down our options, or how many possibilities we have, so 5 times 4 times 3 times 2 times 1, and we want to remind ourselves, remember where this all comes from. We don't want to be so calculator heavy that we just plug those in. So in saying that, I am now going to take my calculator and utilize it since it is an efficient method. But I also understand the process before I'm doing it. And that's really important. Calculators are a great tool, but only when you understand the process that's going into it. You don't want the calculator to be smarter than you. All right, and you get an answer that says 15,504. So that's permutations and combinations, and I hope that was all useful for you. It was a pleasure working with you guys today, and glad to have had you join us. So, until next time, take care. Oh, and totally kidding about the quiz. Wink, wink, nudge, nudge.